What we talked about last week was the likelihood that humans will set foot on Mars soon. I wanted to convince you that that's a very real possibility. I'm just going to assume that you now believe me on that one, right? Whether we get there in 5 years or 10 years or 25 years, unless something happens to change the course of modern history, we're going to Mars. All right, that's where we were. Now we're going in a different direction. Now I want you to understand Mars and what we actually know about Mars. So let's start here. A lot of words. You don't have to read all these words. They might be too small to read. I don't know. But the principle of plenitude is an idea that's been around for 2,500 years. The principle of plenitude, I sum up with the statement at the top there: extraterrestrial beings must exist because God's goodness demands that all worlds, the sun, the moon, Mercury, Venus, Mars, Jupiter, Saturn, all the stars, any other objects out there in the universe, they all should be populated with intelligent, God-worshipping denizens. Why? Because God would not have created those worlds unless they had creatures on them to worship God. That's essentially the principle of plenitude, though it didn't start quite that way. The idea can be traced all the way back to Plato. Plato had his idea about the ideal universe, and in his ideal universe, all possibilities must exist. Therefore, if there are other worlds, the possibility that life could exist on them must be real. Epicurus, who lived a century after Plato, said that every possible explanation is true somewhere in the universe. That idea then became manifest in early Christianity with St. Augustine, who argued that it's better to have a universe full of all kinds of beings, even if some of them are bad. Right? And 1,000 years after Augustine, Giordano Bruno, who was not much of an astronomer, but he's remembered in astronomy courses quite often because he got burned at the stake effectively for saying that Copernicus was right and the Earth orbits the sun, though he was burned at the stake for all sorts of heresies. He did say that we live in an infinite universe with an infinite number of beings. So this idea of the principle of plenitude goes way, way back. And in 1600, at about the time that Giordano Bruno left this planet, that is also the time when somebody else got involved in astronomy, this guy Galileo, who invented sort of the idea of a telescope. Galileo didn't invent the telescope. A guy named Hans Lippershey in the Netherlands really came up with the idea. But Galileo made it better. Right? And Galileo pointed it at the heavens and discovered some stuff. So 1609 ushers in the age of the telescope. In the beginning of the age of the telescope, astronomers, philosophers, theologians, anybody you choose, embraced this idea of the principle of plenitude. All other worlds must have life on them. So at the beginning of the age of the telescope, this is what astronomers assumed they would find. I want to take you through some of the objects we know about. Here's one. You're familiar with this guy, the moon. Early astronomers talked about lunarians, lunatics. Meant something different at the time. But they assumed that the moon was populated. The dark areas on the moon, which are referred to as mare, is the Latin for seas. Early astronomers assumed those were indeed seas on the moon, that the moon had water. Galileo discovered that the moon had mountains, that it wasn't a perfectly spherical object. The moon was Earth-like. But once astronomers truly started poking their telescopes at the moon and studying the moon, they realized that the moon had no atmosphere. Understanding the laws of physics and gravity meant the moon is a smaller object than the Earth. Its gravity is weak. It couldn't hold on to an atmosphere. And by the 19th century, astronomers had proven that the moon indeed had no atmosphere and had no water, had no seas. The moon was barren. No one can live on the moon. So the moon was a forgotten object in terms of the principle of plenitude. The sun. Now, you and I would think the sun's a pretty hot place. You can't live on the sun. Early astronomers didn't think quite that way. They said there could be Solarians who lived beneath the surface of the sun, where maybe it wasn't so hot. Then they started thinking a little bit more carefully, thinking about what physics really means, and recognized that the sun is just a ridiculously hot place. and there's nowhere to live unless you're a hydrogen atom. Okay? So life is not anywhere on or beneath the surface of the sun. So the sun disappeared from the principle of plenitude. Mercury is the closest planet to the sun. Mercury is like the moon, we know that now, but to early astronomers, Mercury was boring. Mercury is just a tiny little point of light. Astronomers couldn't see any structure on Mercury. They couldn't resolve it into a large object to study. Certainly Mercury was hot. We now know that Mercury is ridiculously hot. In the daytime, the temperature is about 800 degrees Fahrenheit at noon. It's almost 300 degrees below 0 Fahrenheit at midnight, and Mercury rotates very slowly, so the day is very long. So it's either ridiculously hot or ridiculously cold, and like the moon, Mercury also has no atmosphere. It took astronomers a while to figure those things out about Mercury, but because Mercury was simply a spot of light ridiculously close to the sun, astronomers gave up on Mercury with respect to the idea of life very early. It was just boring and hot, so there can't be life there. Venus is the next planet out from the sun. I've got a number of images of Venus. The top left is what Venus looks like through a very, very good optical telescope. That's how your eyes would view Venus. For the first 300 years of astronomy, Venus did not look that clear. Venus just looked like a white blur. No structure, no content, no information. Venus was simply boring. And astronomers couldn't learn anything about Venus, so astronomers gave up on Venus and decided Venus was uninteresting and probably doesn't have life. The idea that Venus is incredibly hot, the surface temperature of Venus is pushing 900 degrees like Mercury, but that's because Venus does have an atmosphere. It's a runaway greenhouse atmosphere. Venus's atmosphere is mostly made of carbon dioxide, but it has sulfuric acid rain. It's not a very healthy environment to be in. The top right image is an ultraviolet image of Venus, and it has this V-shaped pattern in the atmosphere. Those are winds that whip around Venus in about 4 days, whereas Venus rotates in a few hundred days. So the atmosphere is very massive and very hot and moves at very high speeds. And because it's so hot, Venus is bone dry. There's no life on Venus. Again, much of that information is 20th century information, but indeed, even in the 17th century, in the early age of the telescope, astronomers just decided they didn't care about Venus because they couldn't learn anything about Venus. Even if Venus has life, we'll never learn anything about it. That was their approach. Jupiter, going out past the Earth and Mars, Jupiter is significantly further from the sun. This is an image from the Juno spacecraft, which is a NASA mission currently orbiting Jupiter right now. Jupiter was very far from the sun, therefore Jupiter had to be very cold, and Jupiter didn't look like much. This great red spot that you see on the top left, the great red spot was discovered within a decade of the invention of the telescope. It didn't change, it didn't do anything interesting, they couldn't see much about it other than it was a big red spot. Moons of Jupiter were discovered, and they were of interest because we could watch them move, but again, they were just little dots of light in the telescope. Jupiter was boring, Jupiter was cold, Jupiter was far from the sun. Astronomers gave up being interested in Jupiter again until modern times. From a modern perspective, Jupiter can't host life. Jupiter's gravity is ridiculously strong, which would make building large structures like houses hard. There's no solid surface. Jupiter is very, very cold because of its distance from the sun. It's mostly made of hydrogen and helium, and Jupiter has a very, very harsh radiation field, which would make life almost impossible anywhere in the vicinity of Jupiter. So we go out to Saturn. This is a beautiful image of Saturn's rings. In the early days of the telescope, it was understood that Saturn was even further from the sun, twice as far from the sun as Jupiter. So again, it's very cold. It was very, very hard to study with telescopes. These rings around Saturn were seen early on. They were described as handles. It took a century for astronomers to recognize that they were actually rings that were not attached to Saturn. But in terms of life, in a modern sense, Saturn's like Jupiter. It's hydrogen and helium. It's cold. It's harsh. There's no life there. And early astronomers also gave up on Saturn. Uranus wasn't discovered until 200 years after the telescope in 1781. By the time Uranus was discovered, the principle of plenitude was fading as an idea, so Uranus never interested anybody for life. Okay? Neptune was only discovered in 1846, and again, by the time Neptune was discovered, the principle of plenitude was simply forgotten. It was a non-principle at that point. So Neptune never became the focus of astronomers' interest in life. And then we have my favorite, Pluto, which wasn't discovered until 1930, and it's too small and too cold, and yes, it's a planet, but that's a whole different story. But Pluto's never been of any interest for life. So taking the entire solar system, astronomers very quickly dismissed every object in the solar system, except this one, as a place where life might exist. And astronomers focused their attention very, very acutely onto Mars early on. And they did so in part because Mars wasn't too far from the Sun, Mars wasn't too close to the Sun, Mars was thought to be similar in size to the Earth, and when you look through a telescope, you can actually see something on Mars, so you can learn something about Mars. So let's start with that. Christian Huygens, one of the great astronomers of the 17th century, took this fantastic little telescope and pointed it at Mars. And when he did so, he saw this dark patch on the surface of Mars. This was the first discovery of anything related to Mars, other than Mars as a spot in the sky. This dark patch really does exist on Mars. We can identify exactly what he was looking at on Mars. It's a structure that's now called Syrtis Major. For Christian Huygens, it was just a dark patch, and he watched it rotate around Mars, and he discovered that Mars rotates in 24 hours. This is the first piece of information that says we know something about Mars, and Mars is an Earth-like planet. This was followed up about a decade later by Giovanni Cassini, who saw this structure on Mars, this milk bone, this dog bone. He measured that rotation period of Mars, and he got a similar answer. He improved the answer 24 hours and 40 minutes. What modern astronomers would now call a sol is 1 day on Mars. 1 sol is a rotation, a day on Mars, and that's 24 hours and 40 minutes. Huygens got this very close, or Cassini got this very close to right. What he was actually looking at here, we have absolutely no idea. We can't identify that. But he must have been looking at something that actually is there. These structures seen by Huygens and Cassini represent coloration patterns on the surface of Mars. That's what they were studying. About 25, 30 years after Cassini did his work, Giacomo Morali got involved. Morali is his nephew, Cassini's nephew. And Morali, in studying Mars, saw these little white patches at what must be the poles of Mars. He discovered that Mars must have ice caps, polar caps of some sort. That's a big discovery. He also pinned down the rotation period more accurately. It's not 24 hours and 40 minutes, it's 24 hours and 39 minutes. We're getting closer to right. He discovered that these dark patches that he saw, they varied in their shape, they varied in their location. Sometimes they seemed to move on the surface, some of them seemed to stay put. He didn't know what was going on with those. The bright polar patches also changed in size, but they didn't change in location. That was Morali's work. Then astronomers essentially took almost a century off from discovering anything worthwhile about Mars. But William Herschel, who shows up in the late 18th century, improved the length of our knowledge of the length of the Martian day, 24 hours, 39 minutes, 21.67 seconds. Okay? He was off by 13 seconds. So it's a pretty good answer, a little over-accurate, but it's a good answer. We know the rotation period of Mars. He studied the polar caps over a long period of time. This 6-year period, he focused his attention exclusively on Mars, and he saw that the polar caps waxed and waned anti-synchronously. The southern polar cap, when it got bigger, the northern polar cap got smaller. When the northern polar cap got bigger, the southern polar cap got smaller. He concluded that must be the result of seasons, that Mars must have seasons. He tried to understand whether Mars had an atmosphere. He recognized in his observations that there were variations in the brightness of Mars. Sometimes it was fainter, sometimes it was brighter. And he attributed that change in brightness to clouds and vapors in the atmosphere, which would reflect more light when there were vapors in the atmosphere. When the clouds weren't there, the light reflected off the surface and Mars looked darker. That's what he concluded. He also recognized that as stars passed behind Mars, more properly we should say, as Mars passed in front of distant background stars, the stars disappear when they go behind Mars, but they started to fade away before Mars eclipsed them, which meant Mars must have an atmosphere extending outward from the limb of the planet, which started to make the stars disappear. So he concluded that Mars had an atmosphere. He then measured the tilt of Mars's rotation axis. So we have the Earth and we have Mars. This rotation axis is tilted with respect to this arrow. My arrow is pointing, I hope, in the direction of the sun. The tilt of the Earth's rotation axis with respect to the direction of the sun is the reason we have seasons. So here's a cartoon of the seasons. The sun is in the middle. The Earth orbits the sun, of course. On June 22nd or June 21st, the Earth's rotation axis is tilted such that the North Pole is pointed in the direction of the sun. The South Pole is pointed away from the sun. And as the Earth spins around its rotation axis, if you're at the North Pole, you have 24 hours of nighttime. If you're at the South Pole, 24 hours of nighttime. 6 months later, at the winter solstice on Earth, the North Polar axis is pointed away from the sun, and if you're at the North Pole, you have 24 hours of night. If you're at the South Pole, 24 hours of daytime. This rotation axis stays fixed with respect to the rest of the universe. As the Earth orbits the sun, the rotation axis doesn't change its orientation with respect to the universe. But it does change its orientation with respect to the sun because you're on one side or the other side of the sun. If you're halfway from the summer solstice to the winter solstice, everyone on Earth gets 12 hours of daylight and 12 hours of nighttime. So everybody goes from winter to summer and back again. But some parts of the Earth have extreme seasons. The Earth's tilt is 23 degrees. Herschel measured Mars's tilt as almost 29 degrees. He got that wrong. The tilt's about 25 degrees. Close enough for government work here or early astronomers' work. Mars is tilted. Mars has seasons. Herschel was right. This is why the polar caps wax and wane. By 1800, I'm sorry, I've got a quote from Herschel here. He spoke to the Bath Philosophical Society, which must have been a really large audience in 1784. And he said, "The analogy between Mars and Earth is certainly more evident than for any other planets in the solar system. Their diurnal movement is almost the same, the 24-hour rotation. The obliquity of the ecliptic, which is the tilt of the rotation axis, causing the seasons, is analogous. Of all the superior planets are further from the sun than the Earth. The distance of Mars from the sun most nearly resembles that of Earth, and as a result, the Martian year is not enormously different from ours." So in 1800, you can compare our knowledge of Earth and Mars this way. The Earth has a 24-hour day, and Mars has about a 24-hour day. Earth has a year of a few hundred Earth days, and Mars has a year of a few hundred Mars days, which are about the same. Both planets have polar caps. Both planets have seasons. Both planets have thin atmospheres. Both planets have clouds. Mars is an Earth-like planet. By 1800, astronomers had established that Mars is like the Earth in all of these measurable ways. If Mars is like the Earth, and the principle of plenitude applies, then Mars probably has life. That was the approach of astronomers in the 19th century. From 1600 to 1800, building up this knowledge of Mars, astronomers did a remarkably good job of getting everything right. Over the next century, they would do a remarkably good job of getting everything wrong. And in part, they would get everything wrong because they started to discover what they wanted to discover. This is where you have to be very, very careful as a scientist. You need to understand what actually is in your data, in your measurements, and interpret what's there, but not put your own biases into the data. Well, they failed to do that. These two folks got us started. William Wolfe Beer was a banker, which meant he had a bunch of money and he could pay for very high-quality telescopes, and he was an amateur astronomer. Johann Van Modeler was a professional astronomer, and they teamed up to study Mars for a period of about 10 years. They used one of the best telescopes that existed at the time, built by a very, very good optical worker in Germany, a guy named Joseph von Fraunhofer. So they had a very, very high-quality telescope. And after 10 years, they completed this map of Mars. This is the southern hemisphere of Mars. So at the center, PS is the south pole of Mars, and you're going upwards in latitude to the equator. So this line would be the equator of Mars. What they discovered is that Mars has dark patches and light patches. They identified a bunch of those patches by letters. We have A, and we have D, and P, and M, and H, and E. This little patch labeled script A is close to the equator and very clear in shape and structure. They liked A. So they decided A would define the latitude-longitude system on Mars, that the equator is clear, but they drew 0 longitude through the letter A, through patch A. That creates on Mars a latitude-longitude system just like we have on the Earth. And that enables other astronomers to make maps of Mars and compare it with this one. They identified both bright and dark patches, and we're going to talk a bit more about those. They claimed that the reddish color of Mars, which was associated with the dark spots, was proof that Mars had an atmosphere. This is where they really started going wrong. The reddish color of those patches proves that those patches have a reddish color. On Earth, he claimed that those reddish patches were proof that Mars had an atmosphere. Why? What do you see that's red in the atmosphere of the Earth? When is the Earth's atmosphere red? Help me out. Sunset or sunrise. So the Earth's atmosphere can be very red. Now, that red sunset follows the Earth as the Earth spins. It doesn't stay in one location. But he deduced that because the Earth has red in its atmosphere, and Mars has this reddishness, that must be proof that Mars has an atmosphere. There's no really good logic to understanding how they came up with this. It doesn't make a whole lot of sense, but it's what they claim. They also claimed that the polar patches were genuinely made of snow. What did they actually know about those polar patches? They knew those polar patches were genuinely whitish. They didn't know they were genuinely made of snow. So they are drawing conclusions they did not have a right to draw. As for those dark and light patches, one could imagine, and they could imagine, getting off of the Earth and looking back at the Earth with a telescope, and you would see light patches and dark patches and white patches. And clearly the white patches are polar caps, but clearly the dark patches are oceans and the light patches are continents. And since Mars is an Earth-like planet, we know the answer here. The light patches are oceans or continents, and the dark patches must be oceans. We knew Mars is Earth-like, therefore Mars must have things that the Earth has, continents and oceans. We've seen the dark patches and light patches. We then sort of anthropomorphized Mars and created the idea that Mars has oceans and continents. Mars has dark patches and light patches. Mars doesn't have continents and oceans. But they were certain that this was the case, and this would remain part of astronomers' understanding of Mars for many decades to come. They wrote in their book they published in 1840 with all these maps, the polar patches are genuinely made of snow, shrinking with the onset of summer. The second part of that's reasonable. As the polar ice melts and evaporates, the surface close to the evaporating snow will become extremely humid. Really? Creating wet, marshy soil. It is not going too far to claim. It's not going too far to claim? Give me a break. It's not going too far to claim that Mars bears a strong resemblance to the Earth, even with regard to physical conditions. So with Beer and Van Modeler's map, they had firmed up the idea that Mars is Earth-like, and they'd added to it. Mars has an atmosphere, which is like the Earth's. Mars has continents and oceans that are like the Earth. And this is the inheritance for the second half of the 19th century for astronomers' work studying Mars. Now let's find some canals. Okay? We're going to talk about canals a little bit today and a lot more next week. This guy, Angelo Secchi, was a very important Italian astronomer at the time, won lots of awards, was very well known, very well, was recognized as a very, very good astronomer at the time. He was the director of the observatory in Rome, the Collegio Romano Observatory. He had lots of telescopes at his disposal. He started making maps of Mars. And this map here is not his map of Mars. This is actually a map that was made by a guy named Richard Proctor, a British astronomer, based on a map made by another British astronomer, William Dawes, which was drawn in 1864. But it represents what Secchi was looking at. We have the dark patches on Mars, and we have the light patches on Mars. And Secchi decided that letters A, B, C, D, E, F, G, etc. were not good enough. These patches needed names. So he started giving them real names. Once you give them real names, they must be real, right? So we have the Herschel continent, and the Dawes continent, and the Modeler continent, and the Secchi continent. He got one for himself. We have the Dawes Ocean. Dawes got a lot of stuff. We have the Beer Sea, the Delambre Sea, the Tycho Sea, the Maraldi Sea. All these things now have names. Now Mars is a much more comfortable, known place. The important thing here about what Secchi did is he looked at this region right here in the middle, in the left-hand hemisphere. That little patch right there, that patch is the little A region that that Maraldi and Beer and Van Modeler had seen. So that's little A near the equator. He looked at this region right here, which we now know of as Syrtis Major. That's the same region that Christian Huygens was looking at in 1859 to measure the rotation period of Mars. It's real, it's still there. But he looked at this, and knowing that this is the Dawes Ocean, and knowing that this is the Beer Sea, and seeing this thing get skinnier and going down this way, it must connect to the Beer Sea. It must be a river, a stream, a channel. In Italian, it's a canal. It connects one big body of water with another big body of water. He called it the Atlantic Canal. In Italian, canal could mean the English Channel. It could mean a river. It could mean a stream. It could mean lots of things, both constructed by humans or natural. But this was the era of human-engineered canals. The Suez Canal. It was in the planning stages in the mid-1850s. By 1859, it was under construction. By 1869, it was built. The Suez Canal was the largest engineering project ever done by humans. It's a big, big project. It is in length 102 miles. If I go back to this map, this thing is half the diameter of Mars. We're talking thousands of miles. If it's artificial, you got some good engineers up there. All right? All right. In 1862, Secchi said, the Atlantic Canal, a name given for brevity to this large blue patch, which seems to play the role of the Atlantic, which on Earth separates the old world from the new. These two canali, the plural of canals for him, enclose a reddish continental area. The reddish regions, like the bluish ones, seem too permanent for their nature to be doubted. It is probable that the former are solid, the latter liquid. And then he said that the variations in the sizes of the polar caps and in the appearance of the clouds proved, I like that, proved, that liquid water and seas exist on Mars, the existence of seas and continents, and even the alternations of the seasons and the atmospheric variations have been today conclusively proved. The underlining is mine. In the same year, this guy got involved in popularizing ideas about Mars. Camille Flammarion was trained as an astronomer. When he wrote this little pamphlet called Plurality of Popular Worlds in 1862, it sold out very, very quickly, so he expanded it published some more, sold it out, lost his job as an astronomer because he was writing books. I got to be careful. All right. In that book, he wrote about Mars, the atmospheric envelopes which surround it and the Earth, the snows which appear periodically over the poles of both planets, the clouds which extend from time to time in their atmospheres, the geographical arrangement of their surfaces in terms of continents and seas, the seasonal variations and the climates common to these two worlds, leads us to believe that both planets are inhabited by beings whose organization is of similar character. Mars must be inhabited. Secchi's found these large canali, which probably indicate there are people up there or creatures up there building them, though Secchi never said that. Camille Flammarion popularized this idea. His book, as I said, it sold out immediately, was reprinted immediately, was translated into virtually every language in Europe. Camille Flammarion was the Carl Sagan of his day. He immediately became the popularizer of astronomy. And in his view, all worlds were inhabited. He still was a subscriber to the principle of Plentitude idea, and Mars was his place. He would tell you there are creatures on every planet, but Mars was the place. With Flammarion's work, building on Secchi's work, building on all the previous work, there is a popular idea out there. And that popular idea out there is that Mars is inhabited by some advanced beings. Now, astronomers were a little bit careful about talking about this for a few decades, but eventually they kind of let it out. Flammarion was not within mainstream astronomy because he stopped being an active astronomer for the most part and became mostly a writer. But astronomers kept studying Mars. This is a map which illustrates, here's your little A patch again. All these things are getting new names, and they're all in some other language than English now, I think. But that little patch there, this guy, William Dawes, who was a British astronomer who drew some really good maps of Mars, he discovered in 1865, and I've put discovered in quotes for you, he discovered that that little patch, which had been named Meridian Bay, because of course it's water, was, in his words, distinctly forked, giving the impression of two wide mouths of a river. In other words, he had discovered that this little thing here was a bay that flows out of this ocean and forked into two rivers. Now, we would reverse that and say the rivers flowed into the bay and the bay flowed into the ocean, but clearly this indicated the presence of two rivers on Mars. Clearly. Okay. He wrote, "Nothing appears more certain than the red tint of Mars is not produced by the atmosphere of the planet." If it's not produced by the atmosphere of the planet, what's it produced by? And he and everyone else in the 1860s were talking about vegetation on Mars. Mars clearly has vegetation that causes the red color. It is autumn, the leaves are turning colors, and for a few days or weeks on Earth, there's some vegetation, like maple trees, that look red. But vegetation on Earth generally is not red. So I'm not sure why they all decided in the 1860s that the red color of Mars proved that Mars was covered with vegetation, because the Earth is not covered with red vegetation. But nevertheless, in the 1860s, that's what they decided was right. They had concluded there's water everywhere on Mars. You got the canals and the rivers and the oceans and the seas and the bays. The red color is evidence of vegetation. What is really needed now is definitive proof that there's water on Mars. And that's about to arrive. I need to introduce you to what's called spectroscopy. Spectroscopy is the idea that you can take light, here's white light from the sun perhaps, you put it through a prism and it is spread out into the rainbow of colors. Producing a rainbow from white light, that's spectroscopy. That's primitive spectroscopy. Isaac Newton figured this out in the 17th century, but it took 200 years for scientists to figure out how to do something with this. In the early 19th century, Joseph von Fraunhofer, this really good German glassmaker who made the telescopes for Beer and Van Modeler, he discovered that when you take light from stars and light from the sun and put it through a prism and spread the light out into the rainbow, you don't just get a rainbow, you get a little bit more. You get a rainbow with dark lines. And early on, these were known as the Fraunhofer lines. And he gave them names, and astronomers were imaginative, so that they were the A lines and the B lines and the C lines and the D lines. This bottom plot helps you understand what's going on. The bottom plot has wavelength on the x-axis, so the wavelength just corresponds to the colors. Think of the wavelength as different colors. And the flux is just how bright the light is, how much light you're getting. This line indicates how much light you're getting. So out here in the orange, you're getting all the light. But when you get to where this dark line is, the bottom drops out. The light disappears. And when you pass that line, you've got all the yellow light, and then the bottom drops out. And again, you've got all these places where the light is missing. Those dark lines are places in the spectrum where the light has been removed. The light from the sun comes out of the sun's photosphere, the light-producing part of the sun, and it's got all the colors of the rainbow. But as the light passes through the outer atmosphere of the sun, materials in the outer atmosphere of the sun can absorb some of the light. The hydrogen atoms can absorb light that hydrogen is able to absorb. The helium can absorb light that helium is able to absorb. These lines that are known as spectral lines, spectral absorption lines, are fingerprints of what some atmosphere is made of. When we look at light from the light from the sun has to emerge from the sun's photosphere, then pass through the sun's atmosphere, then pass through interplanetary space, and then pass through the Earth's atmosphere to get to our telescopes. The sun's atmosphere, interplanetary space, the Earth's atmosphere, all three of those environments can impose fingerprints, spectral lines, on this spectrum. Interplanetary space, there's not much there, so interplanetary space doesn't do much. But the sun's atmosphere does, and the Earth's atmosphere does. So when you're using a telescope on Earth, you have to recognize that you're looking through the Earth's atmosphere. And some of these dark lines that you see are terrestrial in origin. You also have to understand that some of that light is coming from the sun, so some of those lines are solar in origin. But some of the lines could come from the object you're looking at. So that's the idea behind spectroscopy. With spectroscopy, you can identify what kind of material is in between you and the source of light. This is a spectrum of chlorophyll. Chlorophyll actually has several kinds of chlorophyll. This is of chlorophyll A. The y-axis here is how much light is absorbed. And again, this is wavelength. Wavelength is visible colors, so this line changes color to indicate what colors of light you're looking at. If the absorption is around 0, 5, 10%, very low, that means most of the light is passing through. The chlorophyll is not absorbing the light. Chlorophyll absorbs most of the purple and blue light, almost 100%. Chlorophyll absorbs most of the orange and red light. What chlorophyll does not absorb is what's in between, the green, yellow light. That's why leaves generally look green, because the sun produces more green light than it produces these other colors. And the light reflecting off the chlorophyll, green is reflected, blue and purple, orange and red are absorbed. So what reflects off the grass, what reflects off the leaves is green. The green color of chlorophyll is the result of the way the chlorophyll molecule behaves. It absorbs certain colors, it reflects certain colors. Spectroscopy allows you, again, to figure out what kind of thing you're looking at or what is in between you and your source of light. And the person who tried to figure that out got astrophysics started in the 1860s. I've got one more slide before I tell you who that is. This is a spectrum of water vapor absorption, because that's what we're interested in Mars. If you want to prove that Mars has water, why don't you look at the light and look at the spectral signatures and look for the signatures of water. So again, this is wavelength. Visible light here is just a very, very small part of this spectrum. This spectrum goes deep into the ultraviolet to the left, and beyond the visible you have what's called the near infrared, the mid, then the far infrared. And so this spectrum covers a large part of the electromagnetic spectrum. Again, this vertical axis is how much light is absorbed, and we don't care what the units are. We just care that if this line is higher, it means more light is absorbed. In the Earth's atmosphere, in the ultraviolet, water absorbs most of the light. If you go to a swimming pool and you go a few feet below the surface of the water, you're completely protected from ultraviolet light. You don't need sunscreen if you spend the whole afternoon 5 feet deep in the water. If you want to breathe, you're going to have to come up and get sunscreen. But the water protects you from that ultraviolet light. In the infrared, this region is the near infrared, this region is the mid infrared, the far infrared. In the infrared, water is a great absorber. This is one of the reasons the Earth's atmosphere warms up. Light from the Earth goes up and gets absorbed by the water. Light from the sun comes down and gets absorbed by the water in the atmosphere. That's part of one of the ways in which the atmosphere warms up. Water is a good greenhouse gas. In the middle here, where we're in the visible, that's what early astronomers were studying. In the visible, most of the light from water, most of the light gets through. Water doesn't do much absorbing in the visible. The absorption is very low. But there are a few places, see these little peaks here, where water is responsible for more absorption. Those little peaks become the signature of water in the spectrum of Mars that early astronomers started to look for. So they could say, if you're looking at light from Mars, there should be less light at that color than there would be if you were looking at the moon, because the moon doesn't have any water. The person who got this game started is this guy on the left, William Huggins, working with the guy in the middle, William Allen Miller. Huggins and Miller in the 1860s invented astrophysical spectroscopy. And in doing so, they really changed astronomy from astronomy to astrophysics. Instead of looking at things and saying, oh, there's a white patch, they started doing physical measurements of the stuff that's there. They invented modern astrophysics through using the tools of spectroscopy. So you take a telescope, you got the light coming from Mars through your telescope, you put the light through a prism, and you get a spectrum, and then you look at that spectrum. This is before modern instruments. You can't record the spectrum on a photograph. You just have to look at it. But when you look at it, you see a rainbow with some light missing. You see those dark lines. You could draw a sketch of what you see, but you're really paying attention to what you actually see. When they did this work in the 1860s, they decided that they were actually seeing water in the atmosphere of Mars. That when they looked at Mars and compared the spectrum of Mars with the spectrum of the moon having no water, the moon is simply reflecting sunlight. So when you look at the moon, you're looking at the same signature lines in the spectrum of the sun that you would see if the moon weren't there. And that same light is traveling to Mars, going through Mars's atmosphere, coming out of Mars's atmosphere, coming to Earth. So Mars's atmosphere could impose its own signature on that light. Now, of course, that light then has to penetrate the Earth's atmosphere, but the light from the moon and the light from Mars both have to penetrate the Earth's atmosphere identically. So any difference between what you see for the moon and what you see for Mars should be attributable to Mars. Mars puts its fingerprints on the spectrum. And when Huggins and Miller did this in the early 1860s, they decided they were seeing water on Mars. Now again, we don't have some nice spectrum to show you because they couldn't take a picture of it. We just have their descriptions of what they were doing. But they were convincing. By the 1870s, there were magazines in England writing about Huggins as being this great hero for astronomy, this person who'd opened the curtains on the universe and discovered definitive proof that the oceans, the clouds, the water vapor existed in the atmosphere of Mars. This wasn't just astronomers looking at pictures and saying, it's a dark spot, it must be an ocean. It's a white spot, it must be clouds. They were taking a spectrum. They were doing chemistry. They were doing physics in making those measurements. Everyone believed them. Everyone assumed this was clear proof that what astronomers had been assuming for a century had now been proven beyond a reasonable doubt. Jules Jensen, who's over here on the right, who looks just like William Huggins. guess if you grow a Santa Claus beard and you're an old white guy, you look the same. But Jules Janssen did the same thing. He tried to test Huggins and Miller's work. He did this at high elevation on a mountain in Italy. He had the bright idea, which really is a bright idea, that if you go up on a mountain, you get above more of the Earth's atmosphere. If you do that, the water vapor is below you. People knew that if you go high enough on mountains, the cloud layer is below you. So he went as high as he could in Italy, up to about 3,000 meters, and he did the same kind of astrophysical spectroscopy of Mars that Huggins and Miller did, but from high elevation. And he believed he found the same answer, that he saw water in the spectrum of Mars. Janssen also is identified as one of the co-discoverers of helium. Helium had not been known on Earth. He discovered during a total solar eclipse.
With that, I will adjourn, right, and happy to take any questions that you may have about this, that, the other thing, or kind of, whatever may be of interest to you. Yep. Yeah. I mean, I think there is some that, if you think about kind of what motivates you to take an action, like it's certainly the case if you're if you're kind of, it's okay, if you're kind of complacent, then you're kind of, because it's, you're going to have to find the polling place, you have to go there, you kind of vote. So, but if you're fired up and you're angry, that's an easier decision for you to make. So I think it is the case that people are kind of more angry, right, are more likely to vote, which is why, or if you think your vote really matters, right, so the stakes are really high. And so that's why in the current context, you see both races, both sides, right, really kind of priming this. Like your vote is pivotal. Like this is going to be, so if you're for Representative Blackburn, right, your vote could be pivotal because this could give Chuck Schumer control of the Senate, right? Or if you're president, or you're kind of there's this anger against, of course he's not really, tackling. He's trying to make it more local, but it's kind of this notion about anxiety or fear. And that's kind of what drives you to vote. And that's why, like, if you look at the difference between midterm elections versus presidential elections, typically, what we find is that whoever the party of the president is, they lose seats, right, in the House of Representatives. Because the people who turn out to vote are ones that are like, this is not what I expected, right? Or I'm more motivated to be angry about this because there's no elected official who will ever kind of do well by their supporters, right? It's just impossible. Like once you get into office, you have to do things and you make people angry. So the best you're ever going to be is before you get elected. As soon as you get elected, you start making people angry, right? And you're kind of decreasing their enthusiasm. And that's Democrat, Republican, it's all sides. Right? Because you just cannot live up to that. And so then people get more angry or kind of more motivated, and they're kind of going to vote up. And most likely than not, they kind of cast a vote against, the person that's in charge. Yep.
Everybody I know that are under age 50, they use their phones for texting, and they don't answer their phones at all.
Yep.
Unless they do is calling. And I'm sure that way too. Are they doing any polling with texting?
So technology is changing, right? So pollsters are trying to figure out how to do this, right? So they try to do recruit people online. So there's like YouGov and there's like SurveyMonkey and there's all these companies that try to do short text. So part of the problem is that the FCC, it's really hard to text on your phone to kind of, you just can't spam people and say, take my survey, right? But people are trying to figure that out. But this is an issue, like for example, that New York Times poll, that report that had Blackburn up by 14 points. They called 23,000 people, and they had 500 people answer the phone. So right off the bat, you're saying, well, who are those 500 people? Like, are they normal? Like, probably not, right? Probably not so much, right? There's a little, but that's true in general. Like, so the response rate was like a 2% or so. So like even here at Vanderbilt, like when we do our Vanderbilt poll, like, and we spend like too much, right? To try to, we call everyone 5 times, we do cell phones, we do landlines, we say we're Vanderbilt, so hopefully, you think that we're somewhat credible. I guess unless you go to UT, so we try to do all that we can to try to build that. Like our response rate is, we're only 10%, right? Only 10 out of 100 actual people, only 10 people answer to us. Back in the day, response rates of surveys were like 80%, 85%, right? Not in the not too distant future. And that's a real concern, right? Because now I'm worried that the people that are talking to pollsters are not like other people. Now, you can try to wait for that, right? So some of that, like we know educated people are more likely to answer the phone, or people are older. So you can adjust for that. But there are other things that are affecting who takes a survey, for example. So, for example, if you're a Republican and CNN calls you up and says, I want to do a poll, you're like, no, thank you, right? Whereas Fox News says, yeah, I'll give you my opinion, right? So when things become politicized, right, that can affect who's answering the survey in ways that it can be hard to control for. So that makes you worried a lot. Because if you're only talking to 500 people out of the 23,000 people you tried to call, well, that seems like not great. And it isn't great. And that's something pollsters are trying to work at, but like, we're all busy now, right? In terms of, not we as pollsters, but like we as human beings. And so you really kind of worry about it. And that's why you got to put a big grain of thought. You know, so Blackburn plus 14, well, it's like plus or minus 28 or 30, right? That's like, we have some kind of crude approximation, but like really not so much. Yep.
Are there rules of who can do polls? Do you have to go through some steps to get FCC approval or somebody's approval, or can anybody get out there?
You could do it, right? So the question is, are there any limitations on who can do a poll? And the answer is like no, right? Anyone can do a poll, right? There's a lot of companies, so you can do an online poll. So if you want to do for YouGov or SurveyMonkey, like you give me a bunch of money, you can do a poll tomorrow, right? You can go to an IVR or a polling house and you say, I want to do a poll, right? And you can buy some numbers and you can call on your phone. So there's no standards, right, that's enforced. Now, there is a national association, right, the American Association of Public Opinion Research. And they do have this transparency initiative of which Vanderbilt's a charter member that tries to enforce best practices, but there's nothing that requires you to do that. Right? And in fact, I don't know if you've ever gotten these polls, but these are, sometimes you'll get these push polls, which are like crazy. Like, do you like Satan? Yes or no? Well, obviously no, right? Do Phil Bredesen had lunch with Satan. How does that, are you more likely to vote for, and so, but they ask these leading questions that try to produce an answer, right? And they're done by advocacy groups, right, where they're kind of weaponizing polling in different ways. And there's nothing that stops them from doing that. Like even credible institutions, like you have no idea what's going on. So I remember like I teach this crazy class, not crazy, but this fantastic class on elections for undergraduates here. And so like they would always have like the thing that always drove me up the wall is that they'd have these debate polls, right? These Insta polls like on CNN, right? So you'd watch a debate and say, well, who won? Let's go to the polls. And the polls say, well, Clinton won by 40 points. And like, well, that, And then you look at, well, who took the poll? Well, it was all Democrats who took the poll, right? Because like someone, like my side won, so I want to tell someone about that. Whereas if you thought your side won, you didn't answer the poll, right? But there's no standards on any of that. Like there's no standard way of weighting. One of my favorite stories was, and I know this is a digression, but the New York Times did a story like during the 2016 election where they gave the same data set, right? The same set of responses to like 6 different pollsters, right? And those 6 different pollsters said, do whatever you want to do, whatever you think is scientifically appropriate, with art. And so the results that they came up with were anywhere from the same data, from Clinton up by like 12 to Trump up by 5, right? So the decisions that you were making as a pollster could push that data around depending on who you thought was. And these were like actual like academics, all with PhDs. But like they let anyone into the room. So I don't know, like my another favorite story was, I don't know if you remember, this is way back when, there was this website that was like Unskew the Polls, right? They got like lauded because he basically said that basically all the polls are too Democrat. The polls are going to be much more Republican in 2012 than we think they are going to be. And so he went through and kind of did all this adjustment to kind of he said there's not enough Republicans voting. And so he kind of predicted like an overwhelming Romney landslide in 2012. Turns out he was wrong. But if you unskew the polls in 2016, he may have looked more, a lot more smarter in the sense that we don't know this stuff. And so you can get formal training, right? You can do survey methods, but a lot of what we're doing, right? Insofar as you put aside people who are just trying to do polls to shake the political debates because the media loves that kind of stuff, but like a lot of it's unknowable. Like what's the electorate going to look like in 2018? I don't know. Nobody knows, right? Nobody knows. But the assumptions that I make about that, or CNN makes it about Fox News, or whoever's doing the poll, can have a real big right, impact in terms of what you think about the gender composition, the young people, the old people, the Republicans, the Democrats. And there's no manual on that. That's kind of where this art comes into. But the problem is that a lot of times that's not being reported in a way that gives you, the consumer, any capacity for understanding that. So I jump in and look like, well, how many Republicans did they interview? Because I know enough to do that. They kind of say, well, that looks weird. Like, I don't trust that poll at all, right? But that's not something they talk about. And especially if you just spent like $30,000 to do a poll, right? You're not going to say to the media, say, well, we did this poll. It's complete garbage because we didn't talk to enough people, or like we don't actually believe the results. So it's problematic. So I think the only defense you have is being an intelligent consumer and just saying, in some sense, just be like, whatever, I don't care about polls. That's probably the best, you know, the person that can put me out of a job. But don't do it. Any citizen Vanderbilt poll, that's good. Anything else, not so much. Yeah. Yeah.
Is there a correlation between money and election results?
Is there a correlation between money and election results? It's hard to know, in the sense, because you see where all the money goes. So, for example, Nancy Pelosi, I can tell you right, is going to win in San Francisco, but she's not spending any of her money. But in like closer elections, I don't know. I mean, I think the science of that is really mixed, and like I'm not sure. Like, even do ads matter for elections? And I'm not sure. Like, I know I should know that as an academic, but like I read the literature and I don't believe that study. Or you know, it's really hard to know, right? Because the only place you see money or you see ads are like really close places. I know I see lots of ads on TV and say, well, that doesn't make me any a little more likely to vote for that candidate. Like, it doesn't matter if it's a positive kind of or, you know, negative ad. I think where it does help is that if you spend it on kind of getting out the vote, if you have kind of people getting to, because that's what matters. And so if you have a better mobilization effort, if you have better ways of getting people to the polls, making sure they're registered, kind of verifying, I think money spent in that capacity has a positive return on investment. The problem is there's also all this kind of whole communications culture where you have to pay ad people and ad buyers, and so you can spend a lot of money in really inefficient ways, right? In which case it doesn't necessarily kind of, you know, turn out. So, but I'd always want more money rather than less money. So that's like a complete evade of your question. So I think that's a little kind of certain. Yeah.
A lot of states have early voting now,
Yep.
Is there any research that shows that impacts things one way or another?
Well, so early, yeah. So I think people are still in the, you know, so there's some states, for example, that have all early vote, right? It's like, you know, they all vote. There's like no polling places anymore. And so I think there are some, so campaigns love that because the light can actually then see if there actually people are voting or not. And so they can lock up votes. Now, what it also means is that if something happens at the last minute, right, in a campaign, right, you've already voted, right, and you can't undo your vote. So I think like it's also easier for voters because it gives them more options to get to the polls, right, rather than having to stand in line, and that can have differential costs depending upon, right, how busy your day is. So I think that there is a movement towards kind of early voting, but there doesn't really seem to be any relationship so far as to whether that benefits Democrats or that benefits, you know, Republicans or kind of nothing that kind of really systematic. I know, like, so nowadays the media is all playing this game like, well, early voting. So this is like, it's like, for example, like in the lead up to 2016, there was, you know, Clinton, if you remember the stories a lot, were like, well, Clinton's doing really good in early voting, right? She's crushing the numbers in Michigan. She's crushing the numbers in Florida, right? This portends very well for her on election day because she's just winning the early vote a lot. And I remember thinking to myself, like, well, geez, I don't know, because are you actually getting new voters to vote, or are you just getting people who were going to vote on election day and now they're voting early? And so you're not actually picking up any votes. And that wasn't it didn't really come across in any kind of the stories, but it turned out that's exactly what happened, right? It's not that Clinton was surging in Florida. It's just that people who vote on election day say, well, geez, there's this thing called early voting where I don't actually have to stand in line on election day. I can just go sometime during the week and cast my ballot early. And so I think that can make it really hard. And so I think you're going to start seeing some stories now about who's winning the early vote, right? And what does that mean? And my answer is like, I have no idea what that means, right? Because I don't know whether that's election day voters who are just voting early, right? Or whether that's new voters into the system. And I don't think we have any idea of kind of knowing because all we see is who's casting their votes. And so it can be very again, misleading. I mean, people love numbers, right? They love to say who's up and who's down. But I don't know how you interpret early voting numbers to kind of say, well, this side is surging, or there's more Democrats that are casting their vote early, or there's more, you know. I mean, I can tell historically there's some groups that vote at differential rates in early voting, but again, the past is not necessarily predictive of the future, and I don't know what that actually means or portends or predicts for votes on Election Day. Yeah? The use of big data? Yeah. So the question is big data, right, going to change all of this? So I can tell you it's like crazy scary, and, you know, about how much data they actually have on all of us, right? So I've been doing a project with some postdocs here, looking at the location of polling places in North Carolina, and like whose polling place gets moved, and what's the impact of having your polling place moved on voting or not. And so it turns out, if you go to the Secretary of State webpage in North Carolina, you can download all that data, right? You can do that right now. So you get a complete list of every single voter in North Carolina, where they live, what their race is, what their party registration is, and kind of what their date of birth is. So you could all do that right now. Like, that's all accessible online, which is like crazy, right? So like, I have a relative who, like, you know, left the family and they kind of moved to, you know, some place in rural North Carolina. So I wonder if he's on the voter file rolls. Yep, there he is. Right? So I kind of look up a street, Google Street View. Oh, that's where he lives now, which is like crazy, right? And that's all publicly available. And so what do companies do? Right? So there's all these voter file companies and parties. And so you get all that voter file data. I have all your information from that you've registered to vote. But then companies are collecting so much data on us on a regular basis, right? So like if you're playing Candy Crush or something on your phone, right? Something that you click through that you give away your location services, right? So then they have a profile about what do you do? When do you use your phone? What stores do you visit? Because they can geolocate you and track you all over the place, right? And who are your Facebook friends? And then I can merge all that in, right, to my voter file. And so now I have a complete list of kind of, here's everyone who's voting in the state, and here's kind of what things they like on their phone. And this is kind of who their Facebook friends are. And oh, by the way, this is what pizza they order, because Domino's has sold me the list about who orders the pizza. And I know what magazines you subscribe to. And oh, I can go to Google, or kind of I go to, Zillow. I'll go to Zillow, because I know your street address. And so I will get your information about how much your house is worth. And so I'm going to merge that in. So now I have an estimate of how wealthy you are based on how long you've lived at your residence and kind of what your property taxes are appraised at. And then I'll kind of buy magazine subscriptions to kind of see what things you subscribe to, because, you know. And so now I have this crazy data, and I guarantee you that they have this, right? Because I've seen it, right? And so now they have data on every single one of us, or they think they know they have data on every single one of us, that may or not be accurate, that they can then like target at the micro level, at the individual level, right? They think they know what your brand of pizza that you like is, or kind of what you're likely to voting, or who you're likely to vote for. And so then they do this thing that they try to predict kind of what you're likely to voting in Democrat or Republican, or what your position on gun control, based on your characteristics or the characteristics of the people who live around you and the type of house you live in, and kind of what kind of things you subscribe to and what organizations you believe in. And so they create these massive data sets, right? And both parties have this. And it's kind of, I don't know, like we haven't gotten to like a super dark place yet, but like it's kind of like you start thinking about like that's not really great, right? In terms of how much information they have about how we interact with our citizens around us, and how we interact with the government, and kind of where we live, and kind of whether or not we vote. And if you really want to be nefarious and evil, right? And then you have my tracking information for my cell phone. Like it's like you can get to like a really scary like dystopian future, like pretty. Not to kind of, freak everyone, but like, it's all out there, right? It's not that hard to do, and you could start a company tomorrow that does that, because in North Carolina easily by just downloading that data, and going for that, right? And so long as you're doing research, right? You can, So I think Tennessee it costs like $20,000 to get the voter file here, but if you're a bazillionaire, right, or if you're motivated, you can have that. Yeah. So why do we vote in such small percentage compared to other nations? I don't know, right? I have some, so some places you have to vote, right? So if you don't vote, it's against the law. So that's compulsory voting. Now, is that a good system where I'm making people who vote to show up to vote? I don't know, right? Because then you have people voting that I'm not saying ought not to vote, but may not be paying attention to kind of politics in a way. But for whatever reason, people, I think more, and this is, I think, if you look at congressional approval, right, the percent of the population think Congress is doing a good job, right? It's like 8%. Right? Everyone thinks our government is horrible, right? And did that change when Republicans take over? No, right? I mean, the Republicans kind of like, oh, this is, I like the Congress. The Democrats are like, well, I hate the Congress because we're a lot of partisans here. But there's not, just like in general, I think there's this system of malaise, right, that seems really pervasive. And I don't know whether it's the 24/7 news or the fact that everything is kind of political, but there does seem to be this sense that, or this sense of disempowerment, I think. And that's not really, that's kind of more just me being a pundit rather than me having like hard actual data. So this is kind of me going a little bit outside my comfort zone. But like, I do think that people have this belief that there's not really a lot they can do. It doesn't matter who they vote for, that they don't see returns on that investment of time in politics in terms of making their life better. And I think that's why you see, I think that was a large story about President Trump, right? People think that I want it, my life's not going pretty well here. Like, I'm going to take a chance, see what happens, right? Or why Ross Perot, right? He kind of surged back in the day, like, let's have a non-politician, right? And because the politicians aren't doing it for us, right? Whatever that is that you want them to do. So, I'm going to kind of check out or try to take an outside option. And so if you don't think the system's working for you for whatever reason, then I think that's a big reason. But it's also kind of like, that's why you never know, right? So you thought that, well, maybe when President Trump was saying the things he was saying about Hispanic voters, that would mobilize them to vote. And it didn't happen. And so then it's like, well, that's kind of in some sense validation, right? So it's, or like young people. Like if young people don't like to do it, but they only vote at 19%, right? Unless they kind of turn around and do something, unless they see the return. So how you break that cycle of the kind of declining turnout, maybe we can make them all Pokestops. I mean, that would like at least get my son. Of course, he's not voting, so that'd be illegal. But so I don't know how you incentivize people to kind of really do that. But I don't think they feel sufficiently invested in the system, except when you get older, right? So when you get older and you experience life and things happen to you, and you realize like, well, geez, like this really matters. But like if I'm a college kid, I'm not really thinking about that. I'm like, well, where's the cool party on campus, right? Or what the heck did Professor Clinton assign me to do? Like that horrible assignment. But I think as you get older, you get a better appreciation of basically all the ways that laws and regulations affect and impact your life, and things happen. So, but how you translate that down, I'm not sure. I mean, I think earlier on, like when the Vietnam was going on, and like you had things that were kind of much more, then you say, well, I could be drafted here, so I better pay it, or civil rights. Like there's things that are going on that impact me a lot more. But I don't, but things are obviously going on right now that's impacting young people, right? And so kind of we'll see. But that's a totally unsatisfactory answer. But like, if I knew that, I knew the answer to that, then I guess I'd still be here. But that's, yeah.
After the election, you're going to want to know who voted, educated or not. When I go, I press my button. How do you know about me that I went to college and all? What do you go to find the data to find out who voted?
Okay, so how do I find out about you? So there's three different ways that that scholars try to get information on you. So one is that I know if you voted or not, because I can look at the voter file after the fact and see whether or not you cast a ballot. I also kind of know where you live, and so the census does this information, does a census obviously, right? So I have basically precinct block level information, which is a pretty small geographic area around your house. And so I can say, well, if you live in this neighborhood, right, then, and I know the census characteristics about things, then I can make an assumption about maybe you're similar to the people that you live around. So I can make some kind of assumption about, here's the people who you live with or live nearby, so you're probably not dissimilar given patterns of how we decide to live amongst one another. So that's kind of one way. We make assumptions based on larger groups, right? So if you live in Davidson County, you are probably different than if you live in Williamson County, right? So I can make assumptions about where you live that informs that. The other thing is that we have exit polls. And so there's like in certain selected precincts around the country that get randomly selected, there'll be actually people at the polls trying to ask people who come out of the polling place, right? And so they're actually going to do this in Tennessee this year, which they don't typically do. And ask, well, how did you vote? What do you think about these different issues? To try to get some sense about it. So they're basically trying to do a survey on the spot of voters who are coming out of the polling place. The other thing, so that's another way. Of course, then you worry about, are the people who actually talk to an exit poll person, are they, because there's response rate issues there because if someone saying, answer the survey, like, who are you? Like, why am I going to talk to you? Like, my vote's secret, kind of, which is an issue, right, with the exit poll. And so you get some people who talk to you and some people don't, and that could be different. And then the third way that people try to figure out who voted is that, again, the census does the survey, the current population survey. So the census doesn't just do the census every 10 years. What it also does, it also tries to track what happens between the 10 years. And so they do this thing called the current population survey. And sometimes they'll kind of match your responses up to kind of voter history, to your voter file. And so, the census is mandatory. And so I got one of these scary looking letters like a couple years ago. It said, you must answer this survey or else you'll be thrown in jail. Like, holy smokes, like, I guess I'm going to answer this. And it was like this really long survey. But like, so that's something that the census did to try to keep track of kind of where our population is and kind of where population growth is. And it's used for like cities and urban planning and rural planning and all these other, and federal money and grants and all that other stuff. But as part of that, sometimes I do these voter supplements where they then try to figure out what the electorate is looking like and where people are living. So then they can use that information to figure out where should I put polling places, where should I put all precinct boundaries, kind of where do we need kind of, keep tabs on that. So those are kind of the three basic ways that people try to figure out what the electorate is. I mean, there's also polls that just ask you, did you vote? But again, anyone who's like, well, I'm an American, of course I vote, right? I'm going to lie. So, yep.
What tools can you give us for drilling down on the polls to get more information? For instance, you said 23,000 calls were made.
Yeah.
And only 500 answered it spiked the black burn over Bryson by 14 points. Where do you find this kind of information?
So that's called the response rate. So one thing you should always look for at any poll is what the response rate is, which basically is how many of actual human beings are there, what fraction of them were they able to talk to. Now the problem is a lot of polls don't tell you what the response rate is, which is horrible, right? And that's a problem because then you have no idea. I mean, the other thing that I sometimes look like, and so I look to see kind of what are some things about the population in terms of what does the partisanship look like. But again, that's just a guess, like in terms of like the Democrat or Republican, or what's some number that I think should be true, right? So for example, what's the approval rate of kind of Trump in Tennessee, right? So does that look about right or not? Or does there seem to be a lot of Republicans or a lot of Democrats? And so, but again, this is kind of where the art is. Like response rate, that's something that's actionable. But even then, like you could have a really super high response rate, right? Well, I guess that's not actually true, but if I don't wait on education, right, then I'm kind of hosed. And you try to read that, like, well, what did you actually do? How did you adjust the results? And a lot of times they don't tell you any idea. So that's like, if they don't tell you, if you can't figure that out, I'd say, well, that's throw in the trash. Well, that's not throw it. But like, I put much less credence in it because if you don't understand what they're doing, right, and if they don't convince you that they know what they're doing, then like, it's just, that's fake news. So a lot of it's online. So sometimes like they'll have a story and they'll say, well, click here for the full results. And they'll click you to some other web page. And so like some survey organizations like Marist has its own web page where you can kind of go see all the results that they're actually kind of doing. And so usually if it's a good story, it'll have a link to the different polls. And then you can actually see what actual questions did they ask. What order did they ask the question? Like, so for example, I know my time's up and they're about to yank my chain. But like, so one thing, so if you think about our current Senate race, right? So if I ask you what you think about President Trump, right, as my first question, right, that's going to get me a different answer potentially if I ask that after I ask you about Bredesen and Blackburn, right? Because the way that the president's involvement in the current Senate race, right, Blackburn trying to embrace him, Bredesen trying to say I'm all about local, state politics, what I placed in your mind as a respondent is going to impact how you answer the rest of your questions. And so that's really important context for you to know. But again, you don't ever get that. You don't know, like, when did you ask that question? Or if I'm asking you, if I'm trying to like move your opinion, I'll ask you a bunch of crazy questions to kind of think about Nancy Pelosi, right, or Chuck Schumer, and kind of how I shouldn't, how that may make you unpleasant. And then say, well, who are you going to vote for? You're going to vote for the Democrat? Right? And you say, well, heck no, I'm not going to vote. But like, you can frame how you ask those questions to get any answer you want. And again, that's not something that now their standards typically just ask those questions straight up. But even then, it can be kind of hard, to do. Or like, do you give a don't know response? Right? So pollsters don't like to give you a don't know response because most people will say, well, I don't know, right? Which is honest, right? Like they ask me, well, what do you think about, this particular policy? I'm like, I don't know, this is my job. Like, it's really complicated. Like, I can see both sides of that. Like, it's, again, not great for TV, right? Because they want black or white. But that's probably the honest answer. It's like, I don't know. Like, I'm still undecided. Like, I see pluses and minuses for this policy or that policy. But that doesn't really help you if you're 90% are kind of undecided. And so then I try to make you force a decision. But if I'm forcing your decision, is that a real decision? Like, well, what does that mean? Like, I've just forced you to arbitrarily come to some position because you want to hang up the phone and get back to eating your dinner with your family. And like, stop talking to me, right, on the pollster, which is certainly not what you want to do at dinner time.
Unfortunately.
Thank you so much.